Hi, this is video A3. This will be our last video over the first lesson, exponential functions. And we're just going to do two examples today. The first is this. I think this is example number 5. So let's say you invest money. You're going to invest $5,000 at 6.25% interest per year. And the question is how long will it take for your investment to be worth $10,000. So we're asking how long is it going to take to double? Okay, and so let's remember our exponential model from yesterday. The amount after that many multiplyings will be the amount we start with. And then we're growing here, so it's going to be 100% plus the rate of growth raised to the t power, and that will be years here. Okay, and so the amount after we're given, so I would label that as a of t. Whoops, that's supposed to say a of t. The amount we're starting with, I would label that as a. This is r. Remember, we're going to convert that to decimal. Okay, and so let's write it out now. The amount we want after is equal to the amount we start with times 1 plus 0.0625, or you divide that by 100, raised to the t. Now this problem is completely different than the ones we've been doing so far. Okay, we've actually never really done a problem like this where we're trying to solve for this exponent. And so where this chapter is leading is we're going to come up with a method to do that for us. For now, we're going to have to rely on our graphing calculators. So we're going to make this y1, we'll make this equation y sub 2. We're going to graph each of these, and then we're going to go ahead and calculate where they intersect. And we've done all that already this year. Okay, and so when we do this, we have to think not only how do I enter these, that's the simple part, what are the window settings going to be? Okay, and so let's go ahead and let me clear out what I have in here. I probably already have these in. Okay, so let's go ahead and maybe I should start from a fresh screen. So hit y equals y1, I'm going to make 10,000. And y2, my second curve, I'll go ahead and make 5,000. And then 1.0625 raised to the x. Okay, we'll make tx here. And if I just hit zoom 6, a standard zoom, I'm not going to see these curves. Okay, think about what we're looking for. We're looking for y equals 10,000. That's a horizontal line. Okay, that's way up at y equals 10,000. So I'll have to go into my window settings. Oh, it's still trying to graph. So remember, you can always hit the on button to stop it from graphing. So I'm going to hit the window button now. Okay, I really don't care about negative x value, so I'm going to start at x equals 0. My x max, now this is kind of a guess. How long do I think it's going to take to double? I think it's probably going to take fewer than 20 years, but I could be wrong. It's just a guess, so I'll make my maximum x 20 for now. Okay, my y min, I'll start that at 0 as well, but then my y max, I have to definitely go higher than 10,000 so I can see both this line and that curve. So I'll make this maybe like 12,000. And now if I hit graph, there I see the horizontal line at y equals 10,000. And then coming up, okay, notice that I started about halfway below here. Well, that's because 5,000 is your starting amount. And since this is a number greater than 1, I see that it's an exponential growth curve, and there's my intersection. So I was right in choosing a number less than 20. Then remember to calculate intersections. Okay, there's the calculate button. So we hit second trace, intersect is 5, and then we only have 2 curves. So I'm on the first curve, I'm on the second curve, and you don't really have to go close. Here's my guess, and then it will give me the intersection down here, and it says x is 11.4 approximately. And so here I'll say t is about 11.4 years. Okay, we honestly should round up so we have more than the 10,000, so maybe 11.5 would be a better answer. Okay, so now I'm going to give you a question, and I want you to make a guess before you touch the calculator with this one. Okay, so this is the question. So let's say that a 1-inch stack of paper, a 1-inch stack of paper is formed by 200 sheets. Okay, and so think about what that means. That means that each sheet would be 1/200th of an inch thick. And so let's go ahead and use the calculator if we need to. 1 divided by 200 and get this in decimal form. Each piece of paper is 0.005 inches tall. So each sheet is 0.005 inches tall. Okay. Let's say you take one sheet of paper, fold one, or no, let's not fold because it's actually impossible. Let's say we cut one piece of paper in half, and then we stack the two halves. Okay, and then we cut the new stack. And so think about how tall that new stack would be. It would just be twice as tall as the one sheet. So double that and it would be 0.01 inches tall. So not very tall at all. But we're going to cut that new stack. That's 0.01 inches tall. Cut the new stack and stack the new halves again. Okay, so think about what we just did. We started with a piece of paper that was 0.005 inches tall. We cut it and put the two pieces, one on top of the other, made a stack, and it was 0.01 inches tall. We took that new stack, cut it in half, okay, and stacked those two parts, and so we have to double the new height, okay, and so it would be 0.02 inches tall. So what I want you to do is now make a guess. Don't touch the calculator yet at all. Okay, if you made, let's say, 50 cuts and stacks, how tall would the final stack be? Okay, so go ahead, make a guess. Don't try to do any mental calculations. Make a guess, and then I'm going to pause. Just pause the video as you're guessing, and then restart it. Okay, so we're going to use our exponential growth model for this. Okay, this is question 6 again. Okay, and so what we're looking for is the height of the last stack. That's the amount after. I'll say h of 50, h for height. Okay, my starting height, we talked about that already, it was 0.005 inches tall. And then I'm doubling every time the height. So I took a piece of paper, cut it, stacked it. It's twice as tall every time. That would be 1 plus 1 as the multiplier. We started with 100% of the height. We're adding another 100%, but very clearly the multiplier should be 2, since we're doubling every time. And we're doubling 50 times. And the units will be in inches. So I'll take the calculator and I'll do 0.005 times 2 to the 50th. And I get this huge number. Remember, this isn't scientific notation. What my calculator says, if you can't see it, is about 5.6 times 10 to the 12th inches. Okay, so that's a really big number to conceptualize. Think about 10 to the 12th. Okay, 10 cubed is 1,000. 10 to the 6th is 1,000,000. 10 to the 9th is 1,000,000,000. 10 to the 12th is 1,000,000,000,000. So 5.6 trillion inches, that's hard to wrap your head around. So let's go ahead and convert that to a more reasonable unit. So you have 5.6 times 10 to the 12th inches. And I know that there are 12 inches in 1 foot. So I could easily just divide that by 12 and get feet, but still it's going to be too many feet. Another thing I know is that there are 5 tomatoes, if you remember that, 5280 feet in 1 mile. And so miles might be a better unit so we can see how tall the stack actually is. So what I'm going to do, notice that the inches reduce, the feet reduce, and I'll just have miles left. So I have this number already in my calculator. So I would multiply by 1, then divide that by 12. I could hit enter. Divide it again by 5280. Whoops, I didn't hit that correctly. I'm going to divide that again by 5280. And I get a huge number again. 8884942.5 about. That's in miles. And I want you to think about that number. That's approximately how far it is from the Earth to the sun. And we got that by exponential growth. And so what this demonstrates is what we mean by growing exponentially. If you're doubling, okay, after 50 doublings, you've grown considerably. Okay, so your homework that I want you to work on are these 2 problems. Once again, go ahead and write them down. Pause the video. Try them. And in a second here, I'll flip this over so you can see the worked out solutions.